All right, so hopefully you took a few minutes there on your own to try the Fanny-Farkle problem, example number 28. And so we are going to read the problem. We're going to do the setup and form equations. Fanny-Farkle selected a rectangular frame to place a picture of furred Berfel. The length of the frame was to be 8 centimeters less than twice its width. So the length here, is to be 8 centimeters less than, so this is minus 8, and it's 8 centimeters less than twice the width. Remember that twice isn't squared, right? That's 2 times something, so twice means 2 times the width. And then what we have up here is this being the width. And remember that when I don't know two things, right, the length and the width, I'm just going to automatically call those variables. So I'm going to call the width my x, I'm going to call my length my y, and then I'm going to get my first equation by saying, oh, width is that, so I have y is equal to 2 times x minus 8. Now my second equation is going to come from perimeter, right? We know that perimeter is equal to 2 times the length plus 2 times the width. So we have that formula right there, and we carry that along with us. Nobody needs to tell us that. We should know that. And that's equal to, and the perimeter of the frame was 68 centimeters. So we want to make sure we write that down. So now, again, we're going to substitute in, right? The length is ry, so 2 times y, plus our 2 times our width is x, and that's equal to 68. So now, between that equation there and that equation here, I have my system. And again, this forms an expression for y, so I'm going to substitute it in and solve. So 2 times 2x minus 8 plus 2x is equal to 68. So I'll simplify this by multiplying 4x and then minus 16 plus 2x is equal to 68. And now I'm going to add the 16 to both sides, and so I'll have 4x and 2x, which gives me 6x, and then we have 8 and 6, which is 4. Carry the 1, so we have 84, and then we're multiplying by the reciprocal, and so 6 goes into 8 one time, and 2 left over, and 6 will go into 24 4 times. So now we know the width of this frame is going to be 14, and those are centimeters, and we don't want to forget the units, right, because units are very important. So 14 centimeters for the width, and then we're going to substitute that in for the expression here. So we know that the y is going to be 2 times 14, and then minus our 8. So we have 28 minus 8, which is going to give us 20. And so we know our length is going to be 20. So the length is equal to 20, and those also are centimeters. Don't forget to write that. And then we can check, right? 20 and 20 makes 40, and 14 and 14 make 28. And so 40 and 28 is going to give me 68, which is indeed the perimeter, and it checks. So hopefully that went well for you. All right, now a little preview of our next topic. Our next topic is going to be on value problems. So you remember total values from a couple of sections ago. That's what we're looking at. A total value problem, remember, is just a modified problem from our linear equations, right? We have some rate of change times an independent variable giving us a dependent variable. And these problems are going to be linked to our following problems, because we're going to see multiplication problems over and over, and then addition problems coming out of those. So more in the next video on that.